This conference will now be recorded. This conference will now be recorded.
Okay, so the agenda for today's discussion is as follows. We are going to start with the concept of cloud computing. In cloud, there are several clouds. Here, our focus is on AWS, Amazon Web Services. Okay, here we are going to discuss about what is cloud computing, then what are the different types of clouds, cloud types, and here what are all the advantages of going for this cloud compared to that of your traditional infra versus cloud. And then what are all the way by which here that is the types here refers to the cloud delivery models, advantages of going for cloud, and then we are going to discuss about the data center architecture of AWS cloud, which is our part of curriculum, data center architecture of AWS, how AWS ensures high availability of your data and high availability of the resources, okay, through its data center. And then we are going to discuss about a service called EC2, how to launch a Linux instance using this EC2. And we are going to discuss about some part AWS storages. Okay, so these are all the things that it is associated with our requirement. So knowledge on cloud. Okay, so I will let you know some small use cases like monitoring, how to do a cloud watch, how to do load balancer, ELB elastic load balancer. Okay, how to do a notification, simple notification services. So these are all some additional steps that you need to go for. What is auto scaling? How to configure auto scaling? Okay. So these are all the services that we are going to discuss. The services by name EC2, and then AWS storage services. Under AWS storage services, we will be dealing with a service called EBS. EBS stands for Elastic Block Store. And then we are going to deal with a service called S3, Amazon Simple Storage, and CloudWatch, Simple Notification, SNS stands for Notification Auto Scaling. These are all the things that it is planned for the next 2 sessions. So now let me start with what is cloud computing. So I will get the assistance of some PPT so that it will be easy for us. And this is the agenda for today's session. Okay. So under AWS, here the agenda for today's session: cloud computing overview, AWS data center, instance and storages. Okay, these are what do you mean by cloud computing? So it is nothing but on-demand delivery of IT resources via internet with pay-as-you-go pricing. Is it making any sense? On-demand delivery of IT resources. Okay. So what is on-demand delivery and where the resources will be there? How you can access the resources? how much that you need to pay for. So if you know each and everything, then you can have an understanding of the above sentence. So before going into this, let me take some analogies. Let me take electricity generation. Let me take the following electricity generation. Here, the electricity has been generated, okay, using some hydro hydroelectric power, nuclear electric power, so on, so on. So if you want electricity, whether you are establishing the own generation station, the answer is no. So here the electricity generation stations involves a huge cost for the investment, and two, it involves a complex maintenance and monitoring overheads. If people doesn't invest anything to set up this infra, instead of that, what we do, we make use of this electricity generated from any one of the infra set up by either government or by third parties like Reliance, and we make use of electricity. And to which extent that we are using electricity, for that alone I need to pay for that. For example, if I consume 100 units of electricity for the month, I need to pay for 100 units. If I consume 500 units, I need to pay for that. If I went for a vacation on that month and doesn't consume anything, I don't need to pay for that. So the key point here is that the infrastructure need not to be established by us. We doesn't have any investment for the infra. We don't need to provide any investment. And two, in case of any maintenance and monitoring, we are not responsible. The third party vendors who establish the infra will take care of maintenance and monitoring. Here, as a layman, as a what we need to have understanding here is, here we connect with this infra and we make use of the services. Here the services here generated here is electricity, and we make use of it in form of a metered service. That we take another analogy, telecommunication. I am having a Airtel. I didn't invest anything to establish the infra like a higher end switching stations, towers, etc., etc. Here, in case of any issues, I am not responsible. Being the user of the infra, I am not responsible in maintenance and monitoring overhead. So here, whenever I need, I can make a call to whom that I am interested, and to which extent that I am calling. For that, I need to pay for that without worrying about this infra maintenance, okay, investment, and so on, so on. So here, similar to this is electricity and similar to this telecommunication. Okay, if we can able to do all the things with respect to our computing needs, what we need in computer? We need the following thing. We need higher end servers. We need storages. We need servers. We need storages data for storing data. We need this software, which may be a system software like operating system, or which may be application software like MS Office, or which may be a databases like Oracle, etc. We may need a software. We may need a networking devices like switches, routers, etc., etc. Internet working devices, okay, networking and internet working devices. Everything that we need with respect to our computing need. What we did so far? So far we need to procure and we need to set up the needed thing. So instead of that, similar to that of your electricity, similar to that of your telecommunication, if you can able to get all those things in form of metered services, then that is called cloud computing. Okay. So here all these iron servers, storages, application software, everything that has been stored on a location called as data center. Who own the data center? The third party vendors. Okay, they may invest in establishing the data center. They may take care of maintaining the data center. And as an end user, myself, Ram, I need a resource. I can make a connection to the data center. For that, what I need an internet connection. I can make a connection to the data center, and I can build the resources of my requirement. What CPU, how much of RAM, how much of storage, what's the operating system, what's the database, everything that I need to build the needed environment, and I can work with the environment, and to which extent that I am consuming the resources, for that only I need to pay for them. This is called as cloud computing. Now if you move back to the first slide, what we have discussed, now you have a clear idea. Okay, cloud computing means it is on-demand delivery of IT resources. On-demand means whenever we need, we can get the resources. Okay, that is on-demand. What are all the resources? It may be a servers, it may be a storage, it may be a operating system, databases, all our computing needs. Where the resources has been stored, the resources has been stored in the data center. So how I can access, whether I need any sophisticated devices or specialized devices on my side to make a connection to the data center? No. What I need here is I need a machine with the web browsing capacity. Any device which supports the web browser is sufficient enough. Using that internet, I can make a connection to the data center and I can make use of the resources there. Okay, how much I need to pay for that? So to which extent that I consume the resources, I need to pay for that. In terms of servers, what I need to pay minimum of time slot of 1 hour. So in terms of servers, and in terms of storages, the amount based upon the data stored. Okay, so I need to pay for that, and I need to pay for based upon the data transfer, etc., etc. So the key thing here is that, so similar to that of electricity and similar to that of telecommunication, if I can get all my computing needs in form of a meter services, is it called cloud computing. So with respect to this cloud, okay, there are basically two types of cloud. One is the public cloud and another one is the private cloud. The combination of public and private cloud forms the hybrid cloud. The public cloud is one which is similar to internet. Okay, the private cloud is one which is similar to intranet. So you know internet. Anyone who possesses an account with internet can able to access the resources. Whereas a private intranet is a network established by within an organization or within a group of peoples. Okay, here the access permissions will be restricted only within that group only. You can't make use of it for other groups. Similarly, here a public cloud is accessible to all those who have credentials with the public cloud. Public cloud providers offer services to multiple customers. Whereas if enterprise level company want to establish the cloud, they establish the cloud on their own. And here only those people working with the company alone can make access to these resources in cloud. It is not accessible to the external users. This is called as private cloud. Some of the commonly used public cloud are AWS. So here these are all the common Amazon Web Services. Okay, and then we have Azure, which is nothing but a Microsoft Cloud, and we have Google Cloud. Almost all vendors. Okay, we call this as GCP. So here we have a Oracle Cloud, we have a IBM Cloud, we have a VMware Cloud, VMware V Cloud, we have Cloud Alibaba, we have cloud from digital oceans. Okay, so there are several clouds, hundreds of clouds. Out of which, who is the leader in terms of infrastructure has been concerned, in terms of servers, storages, etc. Those are all the big forms infrastructure. AWS marketplace is almost 60%, closely followed with Azure. Okay, so in terms of application development has been concerned, Azure is having an upper hand over AWS. Okay, so if you go for image processing, if you go for data analytics like stuff, machine learning, image processing, okay, so Google Cloud is the preferred choice. If we go for this Oracle databases, then Oracle Cloud. If we go for IBM products, then IBM Cloud. So here, altogether in terms of infra, the world leaders are Amazon, continuously for 8 years. So Amazon Cloud was established in the year around 2005 or 2006. Okay, so now they are the pioneers in the infrastructure. So that is the reason why we go for focusing on Amazon Web Services. Okay, so this is a public cloud where the establishment of data centers and management will be taken care by the Amazon. Whenever we need, we can make a connection and we can make use of the resources. Okay. So then what is private cloud? The private cloud is what? Here, imagine an enterprise level company like Wipro. Wipro is having around in India around 100 branches in India. let me assume. Okay, so here they have a data center, a primary data center at Mumbai. On all other branches, people working with Chennai, people working with Coimbatore, people working with assume that the people working with the remaining branches. Okay, so Bangalore branch, people working with Noida, everyone, people working with Run. So everyone, they can make a connection to the data center and they can make use of the resources. Here, the Wipro need to invest to establish the infrastructure. And here the people working with this Wipro alone can make use of the resources. Others is not permitted. Okay, so this is the example of private cloud. So here some of the tools that we use for private cloud is OpenStack. It is one of the most widely used private cloud, which was belonging to a Linux corporation, Red Hat Linux. Okay, so Red Hat Linux has developed this OpenStack, and we have Open Nebula, the another tool. We have another tool called Ecliptus. So these are all some of the commonly used tools for establishing the private cloud. Even we can make use of this Azure. Okay, Microsoft Azure also have an option of establishing the private cloud. Here, private cloud means that particular company need to establish the infrastructure and they need to maintain the infrastructure and they need to develop some user interfaces which provides the infrastructure in forms of services. Okay, none and more importantly, the infra is accessible only within the organization only. It is not open to outsiders. This is a difference between a private cloud and a public cloud. In certain cases, we may need of a combination of private and public cloud. Okay, for example, let I take here. So Wipro organizing development. Okay, so for freshers, they want to provide a training for 2 months. Okay, for 2 months for 300 freshers, they recruited and they want to provide training on Java, Python, MySQL, that is MySQL, and some basics of some Git, some Gitter, and some Jenkins. Okay, let me take. They want to provide training in the following skill sets. Okay, so for 300 freshers, assume that Chennai office is having a employee strength of 1,000 employees. These 1,000 employees of Wipro already accessing the data center of Wipro. Here, these 300 freshers, the duration is only on November and December every year. So for this, they couldn't establish the infra. Okay, it is not advisable to go for infra. If they want to accommodate 300 freshers, they need minimum of 20 cents of lands. Okay, a per cent land in Chennai like cities, it costs in terms of crores. They couldn't invest up to 10 to crores, and for infra, they couldn't invest plus or minus 2 crores to procure these machines to set up everything for 2 months. After that, it will be kept idle. Instead of that, what they can do? Okay, here, and also the people being their freshers, they won't be permitted to make use of the private cloud. So because the private cloud consists of some informations which should not be open to the external world. Okay, the people doesn't aware of what to do with. If they given a chance to make use of it, there is a possibility that it may be corrupted up. So they won't also provide access to the existing resources. Instead of that, what they can do, they can get some instances for this 300 freshers. They can get some instances in computers from a public cloud like Amazon or Azure. And what they need on the side, they need a system with a web browser. Okay, so that it can be a laptop, or it can be a desktop, or it can be a tablet. The tablet, they can purchase a tablet and they give out to these freshers, and then using this tab, they can make a connection with the data center and they can work with that. So here in this case, that is one possibility. Here, the location of Chennai, where 1,000 employees of Wipro making use of the private cloud of Wipro. At the same time, the 300 students, okay, they are making use of a public cloud from Amazon. both coexist under the same premises. This is one example of a hybrid cloud. Let me take another scenario. Here you have a 10 node cluster. Okay, assume that you have a 10 node cluster for data processing. Suddenly you want to do process additionally, you need a plus 5 more machines. Okay, plus 5 machines you need up. So here the additional data processing that need to done only for a week. Is it advisable for 1 week you can procure 5 machines? Whether the company permit to procure 5 machines for your 1 week processing, they won't. Assume that there's a 10 node you are using in your private cloud. But if you want 5 machines which couldn't be accommodated, also because already the private cloud is already occupied, and if you want 5 more machines, what you can do, you can get those 5 more machines from a public cloud, and you can make this private and public cloud to work together, okay, with the 15 machines, okay. And then once your activity has been over, you can release these 5 machines that you have acquired from a public cloud. In this, both the machines 1 to 10 belonging to private and the machine 11 to 15 belongs to public cloud coexist. This is an example of hybrid cloud. This is a scenario where we can go for hybrid cloud. So these are the basic types of cloud. Okay, public, private, and hybrid. Any doubt up to now? Is it clear? If you have any doubt, please let me know. Arun, Balaji, Dinesh, Prakasi, Rajesh, Sham.
No.
So now we have an idea of what is cloud and how to access a cloud. What are all the resources that you need to access a cloud? Okay, so here what are all the different delivery models, public, private, and hybrid. To make you more understandable, I will let you know with a small example. Okay, so the main benefit of cloud is cost. Cost-wise, it is very, very cost effective. How I can make it? Let me take it with a small scenario. Okay, so now I am a freelancer. Assume that I am a freelancer. Okay, I got a project, image processing project. The duration that I need to complete within 3 months. If I successfully complete, I will be compensated with 5 lakhs. Okay. So here, being it is image processing, it involves huge volume and huge storage and huge processing. Okay. Huge storage and huge processing. The infra that it is in need for develop and test my application. It is assumed that I need a machine with 8 microprocessor and I need a machine with 64 GB of RAM memory and with I need a machine with 10 TB of hard disk. These are all my hardware requirements. And in terms of software, assume that I am in need of a Windows Server 2016 with Oracle as my database, Oracle 12c. These are all my software requirements. What I am currently in possession here is, I am currently in possession of i3 with 8 GB of RAM and with 1 TB of hard disk with the Windows 10 as my operating system. This is currently I have in my laptop. But my requirement is this server, a server with 8 microprocessor, 64 GB and 10 TB with a processor. So how much that I need to invest if I go for a traditional way? For this server, it comes around 3 lakhs and to 3.5 lakhs. And for the Windows server at Oracle, it comes around 1 lakh. Totally, I need to invest 4.5 lakhs to procure this infra alone. Then I work for 3 months. Okay, I success itself, I will be compensated with 5 lakhs. But I need an infra for 4 lakhs. The remaining amount that is left out is 50,000. Anyone agree this? Nobody agree. Also because working for 3 months intensely and awarded with 50,000 is not at all a good thing. And two, if I procure the infra, then I am not sure that whether I get another project, I make use of the infra again. Infra, there is a possibility maybe lying idle. So here, this is the way by which if we go for a traditional way of procuring the server and do the process. Instead of that, what I can do? So instead of purchasing this infra on my own, what I can get the infra from a cloud. How much I need to pay for that? The same infra. 8 microprocessor. Totally what I need this infra for 3 months. Let me take an average. Okay. So per day, I am need of average of 5 hours per day. Totally what is the duration into 90 days. Total what I need 450 hours. Let I round off to 500 hours that I need to infra for developing and testing my application. For that, if I go for traditional way of procuring, I need to invest 4 lakhs. Okay, instead of that, if I get it from cloud, this infra in AWS cloud will cost around in Indian rupees around 50 rupees. Okay, totally 25,000 that I need to invest for my infra. Remaining after successful, I can drop the infra, I can give back the infra, and out of 5 lakhs, I will be benefited with the remaining 4.75 lakhs as my compensation. So now everyone will agree to do the project. So this is the way by which I no need to worry about the infra. I no need to worry about this maintenance. Whenever I need, I can make a connection to the cloud and I can build the needed infra and I can work with the infra. Whenever I completed my task, I can return back my infra. Okay, this is the way by which we can make use of cloud for our requirement with high cost effective solutions. Is clear? Feel free if you have any doubt to clarify. Balaji and Pragati. So today we are going to start with this cloud. We devoted 4 hours of session for cloud. Also because the entire infra that we are going to make use of it for our DevOps starts from GitHub, Maven, Jenkins, Puppet, Docker, Kubernetes, Terraform, everything that we are going to make use of cloud. So that's the reason. Since many of them doesn't know cloud, so today and tomorrow we will be dealing with cloud. You guys both join later, doesn't aware what is going on. So this is the information. Yes, Balaji, clear? Pragati?
Oh, okay, understood.
Okay, so these are all the different types. Okay, now you know what is the model. Okay, what is public cloud, what is private cloud. Okay, so these are all some of the Amazon, Rackspace, Azure, OpenAbla, or hybrid cloud. And public cloud services are delivered to the client via internet from third-party service provider. Private cloud services are managed and provided within the organization. Okay, so there is a combination of services provided from public and private cloud, which we call it as a hybrid cloud. Okay, these are all the services. So here, infrastructure as a service, platform as a service, software as a service, database, storage, Hadoop as a service. Okay, these are all some of the services. Please make a note. Okay, so here we are going to make use of a service called infrastructure as a service from AWS, and the services that we are going to use is EC2. EC2 stands for Elastic Compute Cloud. This is the service that we are going to make use of in AWS. EC2 stands for Elastic Compute Cloud. Here we are going to create the infra, that is the server that it is needed for our requirement. Okay, using this EC2. So laterly we will be dealing something on the storage as a service. In storage as a service, we will be dealing with some basic storage. Please make a note.
Sir, end of this session, is it possible to forward this PPT, sir? Yes.
PPT I won't forward. So because PPT is confined with this particular company.
Oh, okay, sir.
I got associate. You kindly make a note of it, that's all. Okay, so now we are going to focus on this AWS infrastructure. Okay, before going into that, so you know what is AWS. Amazon initially started with the consumer business, and then laterly now they are in IT infrastructure business. They call it as AWS, and they started implementing cloud in 2005-6, and that come into existence for end user realization in the year 2009-10. Okay, so here the advantages of going for cloud. These are all the main advantages of going for cloud. Elastic capacity, quick and easy deployment, no capital expenditure that we discussed now. Pay as you go for what you use. To which extent that you are using, you need to pay for reusability. We can reuse the component of cloud and everything can be automated. Now what is elastic capacity? Elastic capacity means according to your workload, you can add or you can remove the resources. Okay, so for example, let me take a small use case. Let me take a small example here. You have a web server. You are having a web server with one microprocessor and 1 GB of RAM. It is assumed that it can able to handle 1000 user requests, okay, per second. So here, the number of user requests, if it is below 1000, no issue. Imagine that we have 1100 user requests. But what happens to the server? It is able to provide services, but with less degraded efficiency, a little bit degradation. If the number of user requests increases to 1500, okay, the server's capacity it can able to handle 1000 user requests plus or minus 10 percentage. It will provide the response, but with the degraded. If the number of requests decreases beyond 50 percentage, the server gets caught with panic and it doesn't know what to do and it gets crashed. The server will down. To overcome from that, what we need to do, we need to go for a concept called as scaling. Okay, you can do two types of scaling. One is vertical scaling and another one is horizontal scaling. What is vertical scaling? Within that server, we have one microprocessor, 1 GB of RAM. You add additional one microprocessor and 1 GB of RAM. Now with the 2 microprocessor and 2 GB of RAM, it can able to support up to 2000. Number of user increases to 2500. You need to add additional 1 microprocessor and 1 GB of RAM within the same server. The process of adding in this manner the additional resources within the same server has been termed as vertical scaling. Horizontal scaling means you have one server with 1 microprocessor and 1 GB of RAM. You can add an additional server with the same configuration, 1 microprocessor and 1 GB, two separate servers. If you want, you can add the third server. Okay, 1 microprocessor, 1 GB of RAM. So by the way, you instead of adding resources to the existing machine as of, you can add a new server. This is called horizontal scaling. AWS support only horizontal scaling, not a vertical scaling. Please make a note. Here, you can go on add the server. What is the limitation in vertical scaling? The number of resources that you can add. If it is a physical server, imagine if it is a physical server, if the number of resources that you want to add, microprocessor or RAM memory, depends upon the number of slots that is available. If there are only 3 microprocessor slots, you couldn't add a fourth microprocessor. Okay, that is the drawback associated with the vertical scaling. Whereas in horizontal scaling, there is no limitation. As a number of machines is in need of, based upon the workload, you can go and add the server. There is no restriction. So these are all the way by which the horizontal vertical scaling differs by. Then in terms of scaling, we have two things. One is scale up, another one is scale down. Scale up means adding the additional resources, adding new resource. Similar to that is called a scale-up. Now assume you have 3 machines, okay, for the total request 2500. Number of requests downs to 500. Whether I need 3 machines? Answer is no. I can able to serve using a single machine. The remaining 2 machines unwanted. I can drop those 2 machines and I can keep 1 machine for my purpose. So here there is a possibility that either I can add a server or I can, in case if it is underutilized, I can release the server. The process of releasing the server is termed as scale down. The process of adding the server is called as scale up. Please make a note. Difference between vertical scaling, horizontal scaling, scale up and scale down. Okay. Okay, so here if you want, okay, so here this is called as elastic capacity. Elastic capacity means you can add the resources whenever you want, either it may be a horizontal or vertical. Here model support a vertical scaling. You can increase your capacity. Okay, so the second thing is that easy and fast, quick and easy deployment. How much of time that you need? Okay, so if you want to establish a server, either a Windows server or Linux server, physical server, okay, you have cost, okay, you have money with you. You want to go to the shop, you need to procure the hardware, you need to procure the processor, the motherboard, RAM, and you need to do assembling. And after that, you need to install and format the operating system and needed. For that, how much the time that you need? Minimum you need 5 to 6 hours. Okay, if you have the enough amount with you, minimum some may need 10 hours. If they are well versed, they need minimum of 6 hours. So here for a single machine 6 hours, you need to establish 10 machines. Therefore 60 hours. More or less you need to wait for 3 days, okay, to do this activity for configuring 10 machines and so on. Instead of that, if you go for a cloud, if it is a Linux, which can be done within a minute. If it is a Windows, which can be done within 3 minutes. Any Windows server that you need to launch needs 3 minutes. Any Linux machine need 1 minute. For a single machine, if there are 10 machines, nothing issue. The same within a minute, I can concurrently launch 10 machines. So this is the way by which you can launch it in an easy and a faster manner. That is the point number 2, quick and easy deployment. No capital expenditure, that we already discussed with respect to a small scenario associated with a freelancing scenario where I need a higher end server with 8 microprocessor and 64 GB RAM. I no need to invest. I can get it from the cloud, and to which extent that I am using. So I need the resources for 500 hours. Therefore, I need to pay only 25,000. To which extent you use that, you need to pay for that. And whenever I need, I can make use of the component and I can do this task in an automated manner. For example, here, if I go for adding the resources or if I go for releasing the resources, I can make use of a service called auto scaling, which did the thing automated manner. Based upon the current workload, it senses the workload. When workload is high, it add a resource. When workload is low, it release the resources. This is the way by which I can do automation, and these are all the benefits of cloud computing. Okay, associated benefits. Is clear? Now we are going to discuss about the architectural perspective. So here, Amazon organizes the resources under the following hierarchy. They have regions. They have availability zones. And they have edge locations. Throughout the world, they have 21 regions. Let me make it. Amazon regions and edge location. Okay, Amazon regions and availability zones. There are around 21. These are all the regions. Okay, global infrastructure. So these are all the areas where they have the data center. In India, they have the data center in Mumbai. Okay, so totally, how many regions are there? 21 regions. Okay, there are 21 regions and 66 availability zones. Okay, so planning around 12 more availability zones and 4 more regions. Where the regions are there? Okay, the regions are there in the following locations. So they have the regions under Asia Pacific, Europe. Okay, these are all the regions. US, North Virginia, Ohio, California, Oregon, Canada, German, Ireland, London, France. Okay, once again Stockholm, Hong Kong, Tokyo, Seoul in Japan. Okay, then South Korea, and here Singapore, Sydney, Mumbai, and Brazil. So these are all the locations where they have the data center. Apart from that, okay, they have two regions, additional two regions. So one is AWS Government Cloud US region, and another one is you have a region in China. Okay, so here apart from these two regions, okay, China and US cloud, you can make use of the resources available in all the regions. Okay, if I make a login, so these are all the data centers. These are all the data centers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So the remaining 4 data centers, 2 in China and 2 in US government cloud. We couldn't access those data centers. So here in US, apart from 21, only 17 is allowed. And within regions, we have availability zones. I'll let you know. Around there are 150 plus edge locations. Okay. So two region in China and two region US government cloud regions. Here, these two data center is accessible only for peoples of Republic of China, and then the two data centers of government cloud. So only the enterprise level companies of United States of America and then United States of America's government companies alone can store the data. So excluding, you can store data in the remaining 17 data centers. And what is availability zone? Assume that in India they have a data center at Mumbai. So you launch the resources and you have data in Mumbai. The Mumbai data center get crashed due to some natural disasters or man-made disasters like tsunami, earthquake, or bomb blast. What happens if you have data only on the Mumbai data center? You will lose your data. You will lose your resources. In order to ensure high availability of your resources and high availability of your data, what is high availability? The data and resources should be made available 24/7, 24 hours a day, 7 weeks a day, 360 days a year. The data should be made available. Whenever the client looks for some information, it should be immediately returned back to the client. Therefore, if you have only one replica, that you couldn't be assured. Instead of that, what you can do here, if they have one primary data center in Mumbai, and they have another sub data center at Pune, somewhat around 100 to 150 kilometers. So this primary data center, this is a standby data center, okay, a secondary data center. So for what reason? To ensure high availability of data. What are all the things that it is stored in Mumbai will be replicated in the Pune also by default. Okay. Therefore, in case of the Mumbai data center get crashed, the user will be redirected to the Pune data center. This is the way by which he can able to ensure high availability. The primary and secondary data centers are called as availability zone 1, availability zone 2. In our why so? Because to ensure high availability, since we have a data center has been divided into sub data centers, we call these sub regions or otherwise called as availability zone. It is mandatory that one region, that is one data center, should have minimum of 2 availability zones. So there is some data center which have 6 availability zones, like North Virginia. It is up to the chart. Mumbai region consists of 3 availability zones. Now you know what is availability zone, what is region. Yes, clear? Yes, can I get a quick response of yes or no? Guys?
Yes,
For
sir.
me, yeah.
Yes, sir. Yes, sir.
No, region is the primary data center. And data center has been subdivided into sub-regions. Those sub-regions has been termed as availability zones. Okay. It is mandatory that one region should have minimum of 2 availability zones. At the maximum here, we have North Virginia consists of 6 availability zones. Mumbai consists of 3 zones. Okay. Now what is edge location? Now in availability zone, you can get anything in your availability zone. Assume that you have your database, okay, which is in US, North Virginia. Here is your database. Okay, so you are from India. You are from Tamil Madurai. Let I make it. So there are 10 machines. Your own user issues a query. Get it from India, Madurai. Select start from employee. So here it is assumed that the employee table is stored in the US North Virginia data center. Here the query travels across internet to reach the data center. It got processed and the result will be returned back to the user. Another user, the second user uses the query. Select start from employee where salary greater than 10,000. The same table need to be accessed. Once again, the query will travel from this second user machine to reach the target and the result will be returned back. So another user select start from employee, your salary is equal to 10,000 and jobs equal to manager. Once again, the query want to travel across the net. Okay. Now, if this is the case, each and every user's query want to reach the data center means the internet will be highly populated unwantedly. it may lead to a performance degradation of internet, and to the end user may suffer a lot of time for retrieval. To overcome from that, what Amazon did is, Amazon established the network called SAN network. SAN stands for Storage Area Network across globe. That network we call it as a edge location, or otherwise called as CDN, Content Delivery Network, where we have only storages. We have only storage, higher end storages. All the storages have been interconnected. Therefore, whenever a user issues a query on a particular table and n number of users need the same table, that table employee will be placed to the nearest edge location. In India, we have edge locations at 5 locations, only at Delhi, another at Mumbai, and third one at Chennai, Bangalore, and Noida, sorry, Hyderabad. These are all the edge locations. For example, I am now, this particular network is in Madurai, let me imagine. So here what happens, whenever a set of users try to access the same table, now it will be placed into the nearest edge location, which is assumed that the employee table will be brought into the Chennai edge location. All other subsequent user requests will be redirected to Chennai, not to the US. By the way, you can able to get the information very quickly. This is the way by which the edge locations provide information to the end user in a very fast manner. Okay, so totally there are around 180 plus edge locations, 150 plus edge locations. Let me check it how many now. Edge locations in AWS. Edge location is where end user access services located. They are located in most of major cities around the world and are specifically used by CloudFront, that is content delivery network. Okay. How many edge locations does AS have? There are North America 21 with geographic regions with edge locations and 2 regional edge caches. Edge location. So 176 currently. Amazon uses a global network of 176 now. The number of edge location is 176 across 12 regions. These are all the locations, edge locations where we have. Okay. The numbers has been specified separately. Edge locations in North. In Asia now we can find in India we have Bangalore. Okay. So Chennai and Hyderabad, Mumbai. Okay, New Delhi. These are all the edge locations in India. Regional edge, Mumbai. Okay, so totally around 170 plus edge locations. Just clear? 176 edge locations are there. So now you know what is a region, what is availability zone, and what is edge location. This is the way by which Amazon organizes the data. They organize with high availability. Any doubt?
This conference will now be recorded.
Now what we are going to do, we are going to launch an instance. For all our practicals, we are going to make use of Ubuntu. This is our operating system. So for all our things, for Git, for Maven, for Jenkins, for Ansible, for Docker, for Kubernetes, okay, and for Nagios, for all our process, okay, we are going to make use of Ubuntu as our operating system. Ubuntu is a Linux flavor, okay. So Linux is a open source. From open source means you can download the software for free, and you can do any alteration on top of it. You can release under the own name. Okay, being it is a open source, if a company install Linux, and in case if it gets stuck with any problem, there won't be a support immediately. The problem need to be posted on the forums, and people in forum who are aware of will respond. It may be a day or two. Okay, it doesn't have a fixed time. Whereas in a production environment, it is not recommended. So without support, if we go up in production and it gets stuck with any issues, you couldn't wait for hours or days to resolve them. So what they did here is some company download the source code and they provide some features on top of it to make easier, friendlier, and support. By the way, we have Ubuntu, Red Hat, okay, and then CentOS, SUSE, Mandrake, Debian, Oracle Linux. Like these are all called Linux distributions. All have 70 to 80 percentage of features common. Whether it is Ubuntu or Red Hat, 80 percentage is common. The core is common. Okay, the core kernel is common. And the remaining 20 percentage, they have added some new features to make the end user easy interface. Okay, and some new features which does not change the overall architecture. So here we are going to make use of a distribution called Ubuntu. Here you can make use of either version 16 or 18 or 14. So any version that now I am going to make use of Ubuntu 16. So for this environment, what I need to do? Either I can go up with the physical machine. I have a physical server. In my physical server, I can create two partition, one Windows partition or another a Linux partition. So that while making a login, you can log into the Linux and you can work with all the things. If not, you can go for the concept of virtualization. You can create, you can use tools like VMware. You can use tools like Hyper-V. Usually you can make use of tools like Citrix. Okay, so all the tools are virtualization software. They call virtualization software. Otherwise, we call it as a hypervisor. Using the tool, you can create virtual machines. Okay, you can create virtual machines. In that virtual machines, you can install the needed stuff. I will let you know what is virtual machine and what is virtualization. Okay. So third way is, one is by installing in a physical server. Second way is virtualization. Third way, you want to make use of any cloud. In cloud, here the backend is virtualization. We create a machine. The virtual machine we create in cloud is called instance. Okay, we can create a virtual machine and we can install the Ubuntu on top of it. Anything, either in VM, you can create a VM and install Ubuntu, or you can directly install Ubuntu in your physical server. You can adopt any one of the following environment. Here we are going to make use of using a cloud and more specifically an AWS cloud. Okay. Now I will let you know what is virtualization. Just a minute, I make use of it. So what is virtualization? Virtualization is the abstraction layer that decouples the physical hardware from operating system to deliver greater IT resource. It allows multiple virtual machines with different operating systems to run in isolation side by side on the same physical machine. Each virtual machine has its own set of virtual hardware. What do you mean by that? A virtual machine is nothing but defined as a representation of a physical machine by software. Okay, a software-based computer that has its own set of virtual hardware upon which an operating system application can be loaded. So, in a first glance, it won't give you any sense if you doesn't aware of virtualization. Once our session has been over, 10 to 15 minutes of the session will make you a clear understanding of what is virtual machine and what is virtualization. Normally, it is an abstraction layer that decouples the physical hardware from operating system. What do you mean by that? Let me take a physical server. So let me take a physical server. What are the things that we have? We have hardware, CPU, RAM, hard disk, etc. Okay. On top of the hardware, what we have? We have your operating system. On top of the operating system, we have your applications running. Okay, it may be a web server, or it may be a mail server, or it may be a database server, etc. So now, let me take the hardware correct, OS correct, application correct. Everything is correct means now you can able user can able to access the data. Now application is correct, OS is correct, hardware down. Whether you can able to access the data, no, you couldn't access the data. Application is working fine, OS corrupted, hardware is fine. Once again, the end user couldn't make access. So hardware okay, OS okay, application corrupted. Once again, the end user couldn't make access. So any one failure will result in the total failure. Okay, that is the thing associated with the a physical server. If you go for a physical server, so all these components are dependent upon each other. The failure of any one of the component, either a OS or application or hardware, resulted in a total failure. Whereas in case of this virtualization, what happens here is, here you have hardware which is separated from your operating systems, which is separated from your applications. Okay, you have all are virtuals. Okay, so here in case of hardware failure, immediately what you can do, you can migrate this application and OS into another hardware. Okay, within a fraction of seconds. So all are independent of each other. The hardware, OS and application are not dependent entities. That is point number one. Okay. Virtualization is abstraction that decouples the physical hardware from OS to deliver greater IT resource utilization and flexibility. It allows multiple virtual machines. What do you mean by that? So instead of, if you want to establish a real-time environment, you need an application server, you need a mail server, you need a DNS server, you need a DHCP server, you need a print server. Okay, so you need a web server, you need a database server. These are all the infra servers that you are in need of. Assume that each server costs 5 lakhs. Okay, you need 1, 2, 3, 4, 5, 6, 7 servers. You need to invest 35 lakhs. And for higher end switches, networking, and okay, all other things, storage spaces, another 30 lakhs. You need to invest 65 lakhs. Each server need to separately kept, and each server need a coolant, air conditioner, and administrator separately. If we go for a physical setup, instead of that, what you can do, you can procure a high-end server. You can procure a high-end server, and this is a physical server. On top of it, you can install some virtualization software like VMware, like Hyper-V of Microsoft, okay, Citrix. These are all some of them. Using this virtualization software, you can create all these machine as a virtual machine, not as a physical machine. All these are virtual machine, okay, which is created on top of a higher end physical server. You can procure a server for 15 lakhs. Okay, higher end server. You can make use of this all the way. Also, because if you make it separately, assume that whenever there is a mapping, the DNS uses. Whenever a new user added, then only DHCP. If and only if you issue a print, then print server works. If there is any access to database, only database server. So it is not 100% utilized effectively if we go for a physical. Instead of that, what I can do, so I can create a physical server and top of it I can launch all the servers as a VM. Therefore, I can assure two things. One, cost is very less. Instead of spending, okay, 65 lakhs, my physical server is 15 lakhs, and my infrastructure, okay, the floor space associated with 5 lakhs. That total infra can be established using 20 lakhs. Whereas if I go for a setup physical, I need to establish a separate floor space and air conditioners for each and every server, and it costs around 65. Roughly, there is a benefit of 45 lakhs. So that is the until my resources has been effectively utilized 100%. It won't be ideal if I go for this virtualization. So these are all the main intention behind is cost effective, less cost for my infra and my effective utilization of my resources. Okay. So this is the advantage of going for this virtualization. Okay. Yes, clear. Now, what here you can create a separate VM and you can assign okay separate each and every VM can be assigned okay its own operating system. Each and every VM will be assigned own resources. Okay, for example, here we can find for my application server, I can assign two microprocessor, okay, 3 GB of RAM memory. Here, I can install Ubuntu on top of it, I can have and for my mail server, 1 GB of RAM memory and while microprocessor, and I can have once again Ubuntu. And for my DNS server, once again 1 GB of RAM memory and two microprocessor, and I can have a Red Hat Linux for my DH server, and for DHCP server 1 GB of RAM, okay, one microprocessor. I can make use of my CentOS and for my print server I uses 2 GB of RAM, two microprocessor, and I can use Windows server for my print server and for my class முடிச்சிட்டு and for my database server. So I can have for my database server I can have 4 GB of RAM and 4 microprocessor, okay, and I can configure either the center, okay. So each and every server, okay, will act independent of another server. I can have a IP address 192.100.10.2, 10.3, 10.4, 10.5, 6, etc., etc. for each and every server. So everything will be under all the resources, the CPUs, RAM memory, and hard disk. Okay, hard disk I can assign for my application server 100 GB. I can assign for my mail server 10 GB. I can assign for my DNS server 10 GB. I can assign for my DHCP server 5 GB. I can assign for my print server 20 GB. I can assign for my database server 500 GB. Right? All the hardware associated application RAM, hard disk, and microprocessor will be acquired from the underlying physical server. Each and everything will act separately. If a user wants to connect to database server, he can make use of a tool like PuTTY, and he need to apply the IP address 192.100.10.7 and username and password credentials. Okay, the user will be connected to the database server. For the end user, it is highly transparent whether he is connecting with a physical server or a virtual server. All the machine act independently. You can start or you can stop the machine without affecting another machine. The database server can be started and stopped without affecting web server, print server. Okay, so this is the way by which you can make use of this virtualization with to build a effective, cost-effective solutions. Okay, so now the second one, it allows multiple virtual machines with different operating systems. We have different operating systems. Okay, Ubuntu, Red Hat, Set, Windows on top of a same physical server. Okay, that is the point number 2. Okay, run isolation side by side on the same physical machine. Each machine has its own set of hardware, RAM, CPU, upon which operating system applications are loaded. Here we have 2 microprocessor, 10 GB of RAM, Ubuntu operating system with the application server. Here we have a 4 microprocessor, 4 GB of RAM with CentOS with 500 GB of RAM. So So this is the way by which the virtualization can be utilized for building a cost-effective solution. Okay. Now Amazon also in cloud also we follow. If you want 10 machines, 10 machines won't be a physical machine. All the 10 machines will be a virtual machine. Okay. What you need to do now? You want to connect with the cloud and you want to use the services to launch those 10 machines. Here, those 10 machines, the virtual machine in cloud, we call it as an instance. Okay, clear? What is virtualization? Hi guys, yes or no?
Yes, sir.
A virtual machine
Yes,
is
sir.
a simulator, considered as a simulator. A virtual machine is a simulator. Okay, so which by using software, you can create a computer. What a physical machine can do can be done by a virtual machine. For the end user, it is highly transparent. Whether it is a physical machine or virtual machine, is highly transparent. So here, Amazon uses which virtualization? Amazon uses Citrix, Citrix Gen virtualization too. Okay. What are all the famous tools? We have VMware. We have VirtualBox. VirtualBox is a tool developed by Oracle Corporation. We have Hyper-V. Hyper-V is a Microsoft tool. We have Citrix Gen. Okay, so here Amazon uses this Citrix Gen virtualization. With this, the basic discussion of what is cloud and what are all the different types of cloud, what is the advantage of cloud, what are the services that we are going to make use of it, then how the Amazon data center has been architected, then what is the concept behind the backend of cloud, that is virtualization, has been discussed. Any doubt with respect to today's discussions, please let me know. Now we need to discuss about how to launch the instance and how to connect with the instance and how to install the software on top of it. The thing that we can have discussion on tomorrow. So if you have any doubt, Arun, Dinesh, Prakasi, Rajesh, Sham, with respect to what we have discussed, please let me know.
Sir, for our practice purpose, we are using all of this free tier, OS and all the stuff. But in the real time world, in the companies, what exactly they will use, sir? Any example of selecting OS? What exactly they are selecting predominantly?
They use our company uses Ubuntu.
Okay, Ubuntu free only, free thing only.
Also, no. It is up to a choice. If we have, we are using free, we have a good team of administrators, so we are not dependent. So we are using free. In some project, what we use for our tool, we have instead of going for Jenkins, we go for a tool like called Bamboo. Okay, once again, 80% same Jenkins and Bamboo, which is a Atlassian product. It depends upon company. Atlassian is a company which provides tools. We
Yeah,
are
Jira
also
kind of apps.
open source tools only.
Oh, okay. So big companies also they use with the like Ubuntu kind of thing. But as you tell that 80% of the architecture is same, remaining 20% is customized based on their need.
Yeah,
That's what
requirement.
based on requirement and reliability also. Reliability and the support also it will be a self-support, sir. For
It all depends upon if a big company means they have enough resources. Being they are open source, okay. I want to let you know the difference. What is distribution? That's the reason why I have insisted that. I
okay.
want to let you know what is Ubuntu, what is, and some may have a confusion. All are Linux family children with small differences developed by different vendors. That's all. To make you understanding, I had that discussion. So tomorrow we will be dealing with how to create and how to install the needed things, and after that we continue with only AWS only. Okay, you can also create account with AWS. I will let you know how to create. So no need to spend even a single rupee to do the practicals on AWS. What you need is you need a credit card. That's all. If not, if you feel that you are not trusting the AWS, you can make use of this virtualization for your setup. I will let you know how to create a virtual machine, how to install all those things on tomorrow. Okay. My recommendation is create a AWS account and do all the things. What you need a credit card, that's all. I will let you know how to create account and other stuff. Okay. Thanks a lot. Have a good day.